Swayam Prabha. Digital India. Educated India.
Hello, welcome to the course Introduction to Sampling Theory. So you can recall that in the last lecture we had talked about the varying probability scheme under with replacement and without replacement, or PPSWR and PPSWOR. So we had seen that in the case of PPSWR it was not troublesome, and we could develop our new variable, transformed variable based on the variable under study, and we had found the unbiased estimators for the population mean, their variance, their standard error, everything without any problem. Now, when we started considering the varying probability scheme without replacement, and particularly the probability proportional to size without replacement, then we realized one trouble. The trouble was that after each and every draw, we have to recompute the initial probabilities of selections of the unit. Why? Because once you draw any unit and you are not replacing it back in the population, so the remaining unit in the population should have the probabilities summing up to 1. So now when the size of the population is changing and you have already drawn one unit, so that unit's corresponding probability is now out of the population, so you have to recompute and redistribute all the remaining probabilities such that their sum is always equal to 1. And based on that, I had shown you that in case if you try to select say a sample of size 2, you simply try to select the first unit or second unit, then how are you going to compute the probabilities? And that itself was a challenge, that in case if you go to the selection of third order or say fourth unit or fifth unit in the sample, possibly that will create more complications. Right. So now in this lecture, what are we going to do? We are going to consider the varying probability scheme without replacement, and we are going to construct the unbiased estimator of the population mean. So whatever be the problem, in spite of having the problem, we have to solve it. So that is what we are going to do. But now tell me one thing, when you are trying to consider the without replacement, then as in the case of PPSWR, you try to transform your variable under study y with something like y upon capital N times pi. And I have shown you that how one can obtain those things. Practically you had tried, actually you had attempted to transform the variable in such a way such that the expectation of every variable is equal to the population mean. Once it is equal to the population mean, then if you try to take the average of the population mean, whatsoever be the value, whatsoever be the sample size, that is always going to be an unbiased estimator, or that is always going to be the same as the population mean, and hence the unbiased estimator. Now we would like to use the same approach, but now I have to consider the order of the observation also, that in which of the draw this observation has been obtained. And then we have to consider the corresponding probability of the draw, and we have to transform our variable under study y in such a way such that it becomes an unbiased estimator, just like in the case of PPSWR. So this is what we are going to do in this lecture. So we are going to consider the estimator based on the order of the observation also, along with the values of the observations. So, let us begin this lecture, and in case if you want to download the slides of this lecture, you can go to my home page where I have uploaded these slides in the PDF format. You can download them from there. And the address of my home page is this home.iitk.ac.in /SHALAB/SP. And if you are facing any problem in reaching to this address, you can also scan this QR code using your cell phone or any free application available on your cell phone, and you can come to this address. And still, if you are facing any problem, then I would suggest that you go to any search engine on the internet, type my name and my institution name, and hopefully you will find the home page, and from there you can download the slide. So now, just for the quick review what we had done in the last lecture, we had introduced the symbol capital UI to be the ith unit in the population, and capital PI was the probability of selection of a UI at the first draw. This is what you have to keep in mind. Right, don't get confused with the P1, P2, Pn of the PPSWR, right. So, and then means at every stage this sum of all the probabilities has to be equal to 1. That is what we have to keep in mind. And then we had introduced one more notation Pi, and inside the parenthesis in the subscript this is R. So, this is the probability of selection of UI at the rth draw. So, obviously for the first draw Pi1 will be equal to Pi. And for the second draw, we had computed this probability, means we had made all the calculations, and finally we had this expression. Now, in case if you try to look at the structure of these two probabilities, you can see that this is not really going to be the same as Pi1 in general, unless and until you try to take all Pi Pj's to be equal to here 1 upon capital N. So, all the probabilities are going to be different. So, this is what I am trying to say here. So, usually this Pi2 will be in general be different for each other for I goes from 1 to capital N. So, now in case if I try to compute this expected value of yi upon Pi, this will change with every draw, and this is going to be a change with each of the successive draw. And this is the issue which makes the varying probability scheme without replacement to be more complex. The only thing is this, that in the first step, because this probability is here actually fixed to be this case here capital Pi, that we know. So, in case if you remember that in the case of PPSWR, we had defined the random variable z to be like this, y1 upon n times p1, and we had seen that this is going to give us the expectation of this one here as to be here y bar. So, because when you are trying to draw the first unit, then there is no difference between PPSWR and WOR, because in both the case you are going to draw the first unit out of the population of size capital N. But as soon as you have drawn the first draw, after this for every draw these things will change. So, in general, if you want to consider any other expectation of this yi upon npi where I is not equal to 1, this will not provide an unbiased estimator or capital Y bar in general. Just like the case in the case of PPSWR, it was providing, but here in the case of PPSWR, it will not provide, right. So, now the question is this, that why this problem is coming? Because in every draw this probability is changing, and because of which this expectation is changing after every draw, right. So, now the thing is this, if you want to solve such a problem, we have to incorporate some more information in our system. So, what we propose here, that now we have some more information available in this sample, which is the order of the observation, that whether a particular observation has been obtained in the first draw, second draw, or say any other draw. Now, if somehow we can incorporate such an information in our statistical system, and we can construct an estimator for the population mean, possibly we can solve this problem. And actually this was achieved by Professor Kesaraj, and he introduced an estimator of the population mean. Right. So now such estimator which are based on using the information on the order of the observation, they are called as ordered estimators or ordered estimates. Right. So in order to overcome the difficulty of changing expectation with each draw, we can now associate a new variate with each draw, and such that we have to do it in such a way so that its expectation is equal to the population value of the variate under study. If you try to see, this is the same thing what we have done in the case of PPSWR also. We had not used y1, y2, yn, but we had used z1, z2 Gadan, and these z's were defined in such a way such that in every draw this z will provide an unbiased estimator of the population mean, that is expected value of small z was equal to capital Y bar. So now the same thing can be transformed, or the same concept can be used in the case of PPS WOR also, and we can define a new type of random variable, just like we had defined the z's in the case of PPSWR, right. And we have to define those estimators in such a way such that they take into account the order of the draw also, right. And based on that, we will try to create an estimator of the population mean, and such estimates are called as ordered estimates. The order of the value obtained at a previous draw will affect the unbiased of the population mean. So that is why now they are trying to adjust it in such a way such that when they are trying to take the individual expectation of the variable, then finally they are going to get only capital Y bar. For example, in the case of PPSWR, whenever you are trying to take the expectation of any of the variable, you are getting only Y bar. Now the question is this: whenever we are trying to take the expectation of all the variable, then they have to be combined in such a way such that their expectation comes out to be capital Y bar. Right. So we are going to consider here such ordered estimators which were proposed by Professor Desraj. Right. So in order to understand that how are we going to construct such estimator, first we are going to understand the case where we are going to draw only two observations. We will make here only two draws. Well, obviously you can ask me that in practice a sample of size 2 will not make any sense, but as I said, that is not my objective here. My objective is this: I want to show you here how are you going to construct this new random variables such that when they are combined together, they will give us an unbiased estimator of the population mean. And so I am trying to take an example of sample size 2 where I can show you very clearly that how the things are happening, and then I will try to generalize it for a sample of size n. Right. So okay, so now first let us consider the case 1 where we are going to consider the Desraj ordered estimator for sample of size 2. That means we have to draw only 2 units from the population, right. So obviously this population will have here y1, y2, yn, and then you will have here the corresponding units will be u1, u2, un. From there you are going to draw only 2 observations, y1 and y2, which are going to take any of the value out of this capital y1, y2, yn, and similarly y2 is going to take any value out of y1, y2, yn except the value which has been drawn in the first unit. Right. So now let us say let y1 and y2, they are going to denote the value of the ui1 and ui2. That means the units which are drawn in the first and second draws respectively, because this I can go from here 1 to capital N. So in the first draw any of the unit out of the population can be drawn, and then in the second draw any of the remaining unit can be drawn, right. So but you can see here that now I am using here a notation like ui1 or ui2 instead of u1 or u2, right, because now we know this is WOR. So in the first draw we have a chance that whether the first unit is selected or the second unit is selected or the capital nth unit is selected. And then in the second draw, the remaining unit except the one means all the units except the one which was selected in the first draw, means any of the remaining unit can be selected. That is why I am trying to introduce here this symbol ui. Inside the parenthesis I write 1 and u, and the subscript I write I parenthesis 2, right, instead of this u1 and u2 that we have done in the earlier case. Right, and this, remember one thing, that small y1 and small y2 are not the values of the first two units in the population. It is not like that small y1 is the value of capital Y1 and small y2 is the value of capital Y2. Right, this is wrong. Yeah, it may be true, but in general this small y1 and small y2 can be any of the values from the population. So now we associate the probability of selection also. So this small p1 and small p2, they are going to indicate the initial probabilities of selection of the units, this ui1 and ui2. Right, that is the thing. Okay. Now I try to construct here, suppose here two variables. Now the same question comes what I posed in the case of PPSWR, that who told us that we have to consider the two random variables like here Z1 and Z2. They are not coming from sky, but some attempt was done, some algebra was done, and people realized that in case if they try to define the estimators in this possible way, or if they try to transform the variable y in this particular way, then what will happen? That expected value of Z1 and Z2, that will come out to be as capital Y bar, and then they can find out the means, because that the expectation of the sample mean will become equal to population mean. Exactly the same thing what we did in the case of PPSWR, but the only difference is that in the first draw we are going to associate the random variable Z1, which is equal to Y1 upon capital N times E1. Here there is no issue. We already have actually seen that expected value of Z1 will come out to be Y bar. But now we are considering the WOR case, and we know that the draws are being affected by the probabilities of units. So we try to modify this Z1 to define Z's for the further draws. And we try to define here Z2 like this, 1 upon capital N inside the brackets, Y1 plus Y2 upon P2 upon 1 minus P1. If you try to see what is this thing in the denominator. If you remember, when we were trying to find out the probabilities of collecting a unit in the second draw in the last lecture, then we had found this probability. And if you try to recall, this was the probability of observing ui in the second draw, given that it was not selected in the first draw, but there was another unit, say this u1, that was selected in the first draw. Right. So if you try to see here, I have taken the help of this probability here. Now obviously you can ask me that why I am putting it in the denominator and why not in the numerator. Right, means another option was y1 plus y2 times, I can say here p2 upon 1 minus p1. Why I am not doing it this way? So this I will be able to answer when I will try to take up when I try to find out the expectation of Z2. Means I would say simply, if you try to find out this expectation in this particular way, this will not come out to be Y bar, but if you try to find out the expectation of Z2, this will come out to be the same as the capital Y bar, although I will try to show you. Right, so that is the reason, that is how we are trying to define the Z1 and Z2, and possibly I think Professor Desaraj also thought on the same lines. Right, okay. So now I try to take these two variables Z1 and Z2, which are corresponding to the first and second draws, and I try to propose that let us try to take the sample mean, the arithmetic mean of Z1 and Z2, and we try to consider it as a sample mean, and this sample mean will help us in estimating the population mean of y bar. And remember one thing, that we are transforming the variable y to z, but we are still trying to estimate the same parameter capital Y bar only. That is, you have to keep in mind. Okay. Now, I try to show you that this z bar is an unbiased estimator of population mean y bar or not. Right. So, it is going to be an unbiased estimator of population mean, but now let us try to see its proof. And this proof will help you in understanding that why this Z1 and Z2 were defined in the way they have been proposed, right. So, first I try to tell you the result. The result is going to be expected value of small z bar is equal to capital Y bar. And remember this condition, that sum of all the probabilities after every draw has to be equal to 1. So, now first I try to find out expected value of Z1. So, this is going to be, because now Z1 is going to be dependent on the first unit Y1. Now, this Y1 can be any of the values out of capital Y1, capital Y2, capital Yn. So, when I try to take the expectation of 1 upon n, Y1 upon E1, then this can be written as 1 upon n expected value of Y1 upon E1. Now, I would like to have your attention at this quantity, that when I am trying to find out the expectation, please try to have a look, because I will be using this expectation once again or a couple of times in the further lectures. So, here I am trying to explain you, later on I will directly use it. So, now this Y1 upon P1 can take any of the capital N values out of capital Y1 upon capital P1, capital Y2 upon capital P2, capital Yn upon capital Pn. Now, I am sure that you do not get confused with the symbol, this small p1 and capital P1. Capital P1 is the initial probability associated with the first unit in the population, and small p1 is the initial probability associated with the first value in the sample. And this first value in the sample can be any of the values out of Y1, Y2, Yn, which have the initial probabilities P1, P2, Pn, right. So, there should not be any confusion. So, now this expectation can be written as say here, just like 1 upon n summation I goes from 1 to n, yi upon say here pi, I will say into its pi. So, now if I try to write down here, this is coming out to y1 upon p1 into p1 up plus y2 upon p2 into p2 up to yn upon pn into pn. Now, this p1 will get cancel out, p2 gets cancel out, pn gets cancel out, and I am going here to get here 1 upon n y1 plus y2 plus up to here y capital N. So, this is the same algebra which we did in the case of PPSWR, but I did it once again here, so that there should not be any confusion that how it will change in the case of PPSWOR. Well, that is the same thing here also. And now, this thing here is simply your here capital Y bar. So, the expected value of Z1 comes out to be capital Y bar, no problem. And you should not have any problem, because you already have done this algebra earlier. Now, the main thing is with expected value of Z2. So, expected value of Z2 is simply going to be 1 upon n y1 plus y2 times 1 minus p1 upon p2. Okay. So, now you see, once you try to take this expectation sign inside the bracket, then finding out expected value of y1 is not difficult. Now, when you are trying to find out the expectation of this quantity y2 1 minus p1 divided by P2, then obviously this actually depends on the draw. Means you are trying to say that this unit, the corresponding unit was selected in the second draw, and it can be selected in the second draw provided it was not selected in the first draw. That is the thing. So, that is why we try to use here this result from the probability theory, that is about the unconditional expectation of conditional expectation. Right, you have done that expected value of y is equal to expected value of x, which is the unconditional expectation, and this unconditional expectation is the expectation of this conditional expectation. That is a very popular or simple result in the probability theory that is taught. Well, so now I can write down this expectation as a expectation E1 and the second expectation, which is the conditional one, as E2. So, the E1 is going to be unconditional expectation and this E2 is going to be a conditional expectation, right. So, this is going to be a condition on the fact that Ui1 was drawn in the first draw. So, I can write down here E1, E2 and this variable over here given that Ui1, and now we are fixing that Ui1 was selected in the first draw. Now, we have to compute this expectation. So, what I propose here, that first let me try to compute this part and then I will substitute it here and then it will help us, right. So, now if you try to look at the term y2 upon p2. So, y2 upon p2 is the value in the corresponding to the second draw. Second draw means you already have drawn the first unit. So, that means there are only capital N minus 1 values left in the population. So, this y2 upon small p2 can take any one of the values which are available in the population and there are capital N minus 1 number of values, right. So, it can take any value except the value which was selected in the first draw. And this type of random variable I am trying to express that this will take any value capital Yj upon capital Pj with probability Pj upon 1 minus P1. Right, that is the same thing that we had discussed in the case of when we computed the probability of selection of the second draw in the last lecture. So, now I can write down this probability as like this, right. Try to consider this part, right, which is the, I can show you here. If we are trying to consider first this part and once we have solved this thing, then I will try to substitute it here and then I will try to compute other probabilities. So, we are going step by step so that there is no confusion at the end. So, now capital P1 is the probability of selection of the unit in the first draw. So, now we are considering the second unit. So, this becomes a constant, right. So, now when we try to take the expectation of this quantity, 1 minus capital P1 will become constant and it will come out of the bracket, there is no issue. But remember one thing, what will happen to this small p2? Will this also become a constant? No, because that is the probability associated with the second draw. So, now we have here expectation of y2 upon p2 given ui1. So, now this y2 upon p2 is going to take all the values here yj upon pj with probability pj upon 1 minus p1 here like this, right. And this summation will go from where to where? This summation will be over all the units in the population except the unit which was already drawn in the first draw. So, that is why this summation will go only over this capital N minus 1 number of units, right. So, since we already have drawn the first unit and that we are trying to denote by small y1. So, that means if I try to take all other values, they are going to be one of the unit except the unit which was selected in the first draw. And if you try to solve this factor, I will try to use here another pen so that you can see this pj get cancelled out. This 1 minus p1 also get cancels out because this is independent of juice. So, that is the constant quantity. So, what you have here is only summation j goes from 1 or say summation over all the units except the unit which was selected in the first draw. So, now I can simply write down here that summation I goes from 1 to n yi minus the unit which is selected in the first draw, which is y1, because we do not know that which of the units out of the capital N units, capital Y1, capital Y2, capital Yn was selected in the first row. But whatever be the unit was selected, its value is being indicated by small y1. So, I try to write down this summation yj here like this. And what is this quantity? This is simply here y total. So, I can write down here y total minus y1, and this is what I am trying to write down here. I hope I have made it clear. Now, in case if you try to now substitute this value here in this one. So, I try to substitute it here. So, now you can see here that you had considered this estimator here like here Z2, and then you are trying to define here Z bar is equal to Z1 plus Z2 divided by 2. So, in order to find out expected value of Z bar, we need to find out expected value of Z1 and expected value of Z2. Now, the expected value of Z2 will become here 1 upon n expected value of Y1 plus E1, that was the unconditional expectation. And the value which was inside the parenthesis, you can see here in the red color, the quantity enclosed in the red color here, that is this quantity which we have computed here as a y total minus y1. So, I am trying to substitute it here. Now, y total is a constant. So, now in case if you try to solve this quantity, this becomes here 1 upon n expected value of y1 minus y total, because y total is a fixed quantity, minus expected value of y1. And now, this expected value of y1 gets cancel out, this is plus sign, right. So, now we have here only y total. So, expected value of y total, that is a fixed quantity which is y total divided by here capital N, which is nothing but here capital Y bar. So, now you can see, if you try to look at this algebra now, which I am trying to show you here in the blue color. If you try to look at this expression, then this will give you an idea here that when you are trying to define this Z2, y cannot define this Z2 in this particular format. Why you cannot take this probability in the numerator? Because if you try to take it in the numerator, it will not get cancel out here. That was the mathematical trick which helped us in adjusting the Z2 such that expected value of Z2 also becomes Y bar. Okay. So, now you can see here you have obtained Z1 and Z2 such that each of these Z1 and Z2 is an unbiased estimator of the population mean, and expected value of Z1 is capital Y bar, expected value of Z2 is capital Y bar. So, now if you try to take here expected value of Z bar, this is expected value of Z1 plus expected value of Z2 divided by 2, which is Y bar plus Y bar divided by 2, which is capital Y bar. So, that means if you try to define Z in this way, then their sample mean of Z1 and Z2 is turning out to be an unbiased estimator of the population mean, right. Now, I will not give you the proof of the variance of Z bar, but you can see here that this is going to be here like this, right. Means the proof is not complicated, but it is a little bit lengthy. So, if you want to have this proof, I will say that I have uploaded the detailed notes on my home page, and from there you can actually have a look. Right, the algebra is very simple, straightforward. The only thing is it is lengthy. So, if I try to show you here, possibly you will get bored. So, that is why I am not doing it here. That is the only thing, right. And we have a limited time. So, I would like to use this limited time to give you some more information rather than doing only the simple algebra. But there is one good thing. Finding out the variance of Z bar has a lengthy calculation, but finding out the estimate of its variance, it is very simple. And that is the reason that the Deshraj estimator became popular, because you see in practice you are not really interested in the variance of Z bar, but you want to estimate it on the basis of sample. So, somehow fortunately this estimator of the variance turns out to be very simple, and we can find it out very easily. So, that is why this estimator became more popular. So if you try to see, if I want to estimate the variance of Z bar, that is this quantity that you have obtained here, you just, it is not possible to just replace the population value by sample values. One can do it, but this is not usually going to give you an unbiased estimator. But now here what we are doing, this is going to give us an unbiased estimator. So when you have a choice for biased and unbiased estimator, definitely we will prefer the unbiased estimator. Okay, so this variance of Z bar is given by expected value of Z bar square minus expected value of Z bar whole square. So expected value of Z bar square will remain as such, and expected value of Z bar we already have found to be Y bar. So this becomes Y bar square. Now, if I want to find out the estimator of this variance, then here I can remove this here E without any problem, but here I need the estimator of Y bar square hat. Remember one thing, that capital Y bar had an estimator Z bar, but it does not mean that Y bar square will have an estimator Z bar square. This is wrong. You have to find it out. Right. So let us try to find out an estimator which can unbiasedly estimate capital Y bar square. Now, just for a common sense, I try to take the help of the structure of Z1 and Z2. Now, if you try to think in a very simple naive sense, both Z1 and Z2, they are going to be an unbiased estimator of population mean. So I think very simply, means I may be wrong, but still I give a try. That I said, okay, if Z1 and Z2 both are individually, their expectations are capital Y bar, then why not to consider an estimator like Z1 into Z2? Because at least the dimensions are going to be matched, that they will be in terms of square. So what I try to do here, I try to consider the expectation of Z1 and Z2. So obviously, when you are trying to take it, then this can be written using the same rule of conditional unconditional expectation. Expected value of Z1 and expected value of Z2 given U1, because U1 has already been drawn in the sample. So now we know, we have proved that this quantity is equal to capital Y bar. So now I try to write down here. So now this capital Y bar is a constant. So this comes out of this bracket, and this becomes a Y bar into expected value of Z1, and expected value of Z1 is Y bar. So now this quantity becomes Y bar into Y bar. This is Y bar square. Right. So now I can see that here Z1 into Z2 is going to work as an unbiased estimator of the population mean. So now what I can do, that I have here variance of Z bar is equal to expected value of Z bar whole square minus expected value of Z1 Z2. This I try to rewrite here. So now obviously, if you try to if you want to take its expectation, you have to simply just solve it. So this is going to be expectation of this quantity, which is expected value of Z bar square minus Z1 Z2, this whole estimator, and this is going to be here Z bar square minus Z1 Z2, right. So this is what I am trying to write down here. So this Z bar square minus Z1 Z2, it is going to be an unbiased estimator of the population variance, right. So you can solve it, you can verify it, that is expected value of Z bar square minus expected value of Z1 Z2. So this is coming out to be expected value of Z bar square minus this is Y bar capital whole square. So this is nothing but a variance of Z bar. So this Z bar square minus Z1 Z2 is an unbiased estimator of the variance of Z bar. So you can see it is not difficult at all, right. Now, in case if you try to substitute here this Z bar is equal to Z1 plus Z2 by 2 whole square, then you can simplify it and you can get here one more form of the variance of Z bar. So this comes out to be Z1 minus Z2 whole square divided by 4. Now, if you want to make it more simple, you want to simplify it here, then you simply try to substitute here the value of Z1 and Z2. So this is the value of Z1 and this corresponds to the value of Z2. You simply try to combine these two terms together here, right, these two terms over here. So you can see here that this will come out to be like this. Very simple algebra. And finally, if you try to solve it, this comes in a simple form like 1 minus p1 whole square divided by 4 capital N square, and y1 upon p1 minus y2 upon p2 whole square. So, yeah, this looks quite interesting form, right. It is easy to remember, easy to implement, because now you know the value of small y1, you know the value of small y2, you know their corresponding probabilities p1, p2, you know the population size. So, you can very easily estimate the variance of z bar also. Okay. Right. So, once you have understood this case of sample size 2, now I can extend it to a general case. That means we are trying to draw here a sample of size small n. So, up to now you have drawn only y1, y2, but now I am going to draw y1, y2, yn. So, now this is very important for you that this up to now whatever we have done, this should be 100% clear in your mind, because you will see in this case it may not be possible for me to show all these steps in algebra so clearly as I did in the earlier case, but the same concept can be extended very easily, right. So, now I assume that we want to get here a sample of size n. So, let ui1, ui2, uin, they are the corresponding units which are selected in the same order in which they have been drawn. And a number of draws, right. So, this unit correspond to y1, this second unit ui2 correspond to y2, and similarly here this correspond to yr, this uir, and uin correspond to yn value. So, these are the population units which have been drawn in the sample. So, this uir, this is again going to denote the same thing, that this is the ith unit which is drawn in the rth draw, right. So, now you are going to collect this y1, y2, yn in your sample. So, they will have some initial probabilities also, small p1, p2, pn. Now, since you already have done small y1, y2 and small p1, p2 in the earlier case, so the same thing is just extended here, right, that these are the initial probabilities. Now, instead of 2 sample size, you have a sample size of n. And now, these capital U1, U2, Un, which are the population units, they have got the initial probabilities like here capital Pi1, capital Pi2, capital up to Pin. So, capital P's, they are the units in the population, and small p's, they are the values of those values in the sample. So, anyway, in the sample also you are going to get one of the values of capital Pi's, right. So, now we try to define the first unit, there is no issue, because for the first draw PPS WR and WR, they are the same. So, I try to define here the same thing, Z1 is equal to Y1 upon capital NP1. Now, for the second draw Z2, and for the third draw Z3, and similarly for the nth draw say here Zn, we have to define a new random variable. So, I try to use the same concept or same methodology which I took in the case of Z2. I had shown you that how I had defined that Z2, or what motivated us to consider the Z2 of that particular form. So, I try to do the same type of algebra first, and I try to see how I can adjust my this Z2, Z3, Zn in such a way so that expectation of each of these Zi's comes out to be the same as the population mean. That is my basic objective, and this gives me this form of Zr, 1 upon n y1 plus y2 plus yr minus 1 plus yr upon pr, 1 minus small p1 minus small p2 minus small pr minus 1. Right. Now, there should not be any confusion in your mind that whether how this Zr is coming from the sky. No, it is not coming from the sky. You have done some preliminary exercise, and based on that you have come to this conclusion that in case if I try to choose intelligently this form of Zr, I will get an unbiased estimator. Right. So, now I propose that okay, let us try to choose the first variable Z1 like this and all Z2, Z3, Zn like this. And then we try to take the sample mean of all Z1, Z2, Zn, which is going to be an unbiased estimator of the population mean. So that I am going to prove, but in this at this stage we have to consider that the sample mean of Z1, Z2, Zn, that is the arithmetic mean of Z1, Z2, Zn, this is going to be considered as a possible estimator for the population mean. And now you have to be careful. I am going to use the same type of algebra what I have done in the past. So in case if you are not clear, I will say try to first revise and then move forward, right. So now I have to basically I want to show here that expected value of Zi is equal to y bar for all, say, or say Zr for all values of r. So we already have proved that expected value of Z1 came out to be capital Y bar for r equal to 2, 3 up to here, and I have to show that expectation of Z cadar comes out to be same as Y bar. That is my trick. This is how I have constructed it. Right. So we already have shown expected value of Z1 equal to Y bar. So I am not going to do it here. Now I try to consider the expected value of Zr, okay, in general. So now I again have to use the concept of conditional unconditional expectation. So now this expected value of cadar means 1 upon n expectation 1 and 2, that means the unconditional and conditional expectation of Zr. Now how this cadar will occur? Zr means you are trying to choose the rth unit, UR, capital UR. So before that you already have selected U1, U2, UR minus 1 in the I draw, right. So this E2 is going to indicate the conditional expectation of the unit which have been drawn earlier. So now this U1, U2, UR minus 1 means UI1, UI2, UIR minus 1, they are drawn in the first R minus 1 draws. So now there is no problem. So now I try to substitute here this quantity is cadar, and I try to consider first this expectation YR upon PR 1 minus P1 minus P2 minus PR minus 1. You can see here that this is the value which is appearing here. I will try to mark in red color, right. This is the expectation of this quantity. Right. So now if you try to use this concept of unconditional conditional expectation, then I can write down here E1, E2 the same quantity given that UI1, UI2, UIR minus 1. Now obviously you already have drawn this expectation. So this thing I can write down 1 minus Pi1 minus Pi2 minus Pir minus 1, and then the expected value of means E2, that will come only here with respect to Yr upon Pr, given that Ui1, Ui2, Uir minus 1 have already been drawn. Now can you realize or can you recall how we had found this expression here? I am marking here it in say purple color. How we had found this expression, that you have to recall, and using the same philosophy, using the same rule, I have to now find here the expectation of this quantity. So what will happen? So now if you try to see, I have this variable here Yr upon Pr. Now this can take all possible values from the population except those values which have been drawn in the first R minus 1 draw. So this can take any one of the n minus R minus 1 values, that means n minus R plus 1 values. So definitely what are those values? Those values I am trying to denote it by here Yj upon Pj, and which occur with the probability capital Pj upon 1 minus Pi1 minus Pi2 minus Pir minus 1. Exactly in the same way as we have discussed the earlier probability P2 upon 1 minus P1. So now the expectation of this thing will become here like this 1 minus Pi1 minus Pi2 minus Pir minus 1, and this summation j goes from 1 to n, but I am making here a star, and then the value of the variable Yj upon Pj corresponding its probability, and from here you can see here this probability is getting cancelled out from here, and this probability is getting cancelled out from here. Now, what is the meaning of this star? If you try to recall that in the earlier case we have taken all the summation except over the first value. So, now the same thing will happen, that this star is going to indicate that this summation what we are trying to write down here, like this one, this is the summation which is taken over all the values of y except the y values which have already been selected in the first r minus 1 draws. And if you want to write it more clearly, it will be something like this: j equal to 1 not equal to I1, I2, IR minus 1. So, I am just writing it like this, summation is star, so that you can write it easily, right. So, all the values y1, y2, yr minus 1, they have been added earlier in the sample. So, they cannot appear. So, the population will take all possible values except these values. So, now if you try to see, this comes out to be here E1 summation j goes from 1 to capital N star yj. Now, you have to simply substitute these values over here. So, now if you remember, your expected value of ZR was 1 upon N E1 E2, this quantity and this variable. So, now you are trying to take this E2 inside the bracket, and you already have computed now this expression here like this: j goes from 1 to capital and star summation and yj, right. And what will happen to now expected value of y1, y2, yr minus 1, that will come out to be capital yi minus 1, capital yi2 plus capital yir minus 1, exactly in the same way as we did in the case of sample of size 2. Now, this summation, what is this thing? This is this thing, all the values except the first r minus 1 value. So, this I can write down here the y total, that means summation I goes from 1 to n capital yi minus all the values in the first r minus 1 draws. So, this I am trying to write here yi1, yi2, yr minus 1, and they get cancelled out with these things, and then finally, I have here y total only, which is a constant. So, expected value of y total will become y total divided by n, which is here capital Y bar. So, you can see here that expected value of ZR also turns out to be capital Y bar, and this algebra will show you, will give you an insight that why we had considered the structure of ZR in that particular way. Now, once you have obtained that all these variables, they are going to be an unbiased estimator of the population mean. So, expected value of Z bar will become here 1 upon n, summation r goes from 1 to n, expected value of ZR, which is here capital Y bar. So, this quantity will come out to be capital Y bar, right. So, Z bar, small Z bar, sample mean of Z1, Z2, Zn turns out to be an unbiased estimator of the population mean Y bar. That is a good thing for us. Now, we have to find out the variance of a small Z bar. The expression for the variance of Z bar in general comes out to be very complex in this case. So, we are not going to do it, but as I said earlier, the estimate of the variance in which we are more interested, that is going to be pretty simple, and that is what we are going to consider here. And we are going to use the same concept, same methodology, same philosophy that we have used in the case of sample size is equal to 2. So, now I can write down here variance of Z bar is equal to expected value of Z bar square minus Y bar square, and if you remember that earlier we attempted to find an unbiased estimator of the capital Y bar square, and we had considered expected value of Z1, Z2. So, now I can make it here more general, say RS. Right. So, now there are two options, means I can have an expected value of Z1, Z2 or expected value of here Z2, Z1. So, I try to consider here two possible cases, that when I am trying to replace this Z1 and Z2 by RS, then there are two possibilities that R is smaller than S, so R is greater than S. For example, in this case 2 is greater than 1, and in the first case 1 is smaller than 2. Right. So, for the first case when R is less than S, expected value of ZR, ZS will become expected value of ZR, and then the conditional expectation of ZS, given that first S minus 1 units have been drawn, and now you already have proved that expected value of ZR is equal to y bar. So, there is no issue at all. So, similarly expected value of ZS will also becomes y bar. So, now this becomes y bar becomes constant, it comes out of the bracket and the quantity remains is expected value of ZR, which is again capital Y bar. So, now this becomes here capital Y bar square, and you can see here that this comes out to be again an unbiased estimator. And then means you can see here that when you are trying to consider the case say r less than s, then ZR will not contribute because the variables with the units which you have drawn are u1, u2, us minus 1. And similarly, if you try to take here the other case where r is greater than s, like this one, then ZS will not contribute in the expectation. And in this case, your expected value of ZR ZS when s is smaller than r, this will become expected value of ZS, and this conditional expectation will be on ZR given u1, u2, ur minus 1, because these units have already been selected in the sample. So, this comes out to be here once again as capital Y bar, and then you have expected value of ZS, this y bar comes out of this bracket and this becomes here y bar into expected value of ZS, which is again y bar, and now this you get here y bar square. So, you can see here the expected value of ZR ZS is also y bar square. Now, I try to combine these things. So, let me try to consider here this quantity 1 upon n minus 1 double summation, r goes from 1 to n, s goes from 1 to n, and r is not equal to s, ZR ZS. So, this will become here 1 upon n minus 1 double summation expected value of ZR ZS. So, expected value of ZR ZS, this is coming out to be capital Y bar square. So, now if you try to open this summation, this will become n into n minus 1 times y bar square, this get cancelled out and you get here capital Y bar square. So, now you have done the job. Your variance of z bar comes out to be expected value of z bar whole z bar square, and instead of y bar square you try to replace this quantity which is obtained here, right. And then I can say very simply that an unbiased estimator of the variance of z bar will come out to be, you just remove this expectation sign and this comes out to be z bar square minus this 1 upon n minus 1 double summation ZR ZS, right. So, this is an unbiased estimator of the population variance. Well, in case if you want to make it more simple, then you know that summation ZR whole square is equal to summation ZR square plus double summation ZR ZS. So, from here you can find out the value of this double summation and you can substitute it here, right. So, we get here that the variance z bar hat z bar square 1 upon n minus 1 n square z bar square minus summation ZR square. So, if you simply try to simplify it, you get here 1 upon n minus 1 upon n into n minus 1 summation r goes from 1 to n ZR minus z bar whole square. So, do not you think that it looks a very simple and nice expression, right. So, that is the advantage of this Desh-Raj estimator. Right. So, now we come to an end to this lecture, and you have learned that how are you going to consider the order of the observations to construct an unbiased estimator of the population mean in the case of PPS WOR. Right. So, this Desh-Raj estimator is going to help us, and we had first considered the case of 2 observations, so that I can understand what is really happening. And after that, what we have done? That we made it more general, and now, but now you can see that the estimator is unbiased even in the case of sample of size n. Yes, finding out the variance was complicated, but that does not affect us, because in practice a user is more interested in the standard error in estimating the estimator of the variance, and you are getting here an unbiased estimator of the variance of z bar. So, this will not hamper the application of this Desh-Raj estimator, and by this way one can easily find an unbiased estimator of the population mean under PPS WOR, as well as an unbiased estimator of the variance of the estimator of the population mean. So, that is the beauty of this estimator, and that helps a lot to all the people who are working in real application who wants to use PPS WOR, that in spite of having all these complications of order, but this charge estimator gives you a good value. So you try to do this algebra your hand, try to understand all the steps very clearly, and you have to understand why I am coming from step 1 to step 2 and step 2 to step 3. That is very important for you. So you try to practice, and I will see you in the next lecture. Till then, goodbye.